Welcome students, this is Chandan Singh Negi. Today we will discuss the chapter first number system. Students, we are already aware about the natural number, whole number and integers. We have already studied in the previous classes. Natural numbers started from the 1. This is 1, 2, 3 and 4 dot dot dot. Why these are called natural numbers? These are called natural numbers because we don't know the origin or who first written these numbers. That's why this is called natural numbers. That is the second one is the whole numbers. Whole numbers are started from the 0. This is 0, 1, 2, 3, 4 and dot 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 to infinity. And third one is the integers. The integers are basically called the complete number. These are started from 0 to positive, 0, 1, 2, 3 dot dot to infinity, and this is -1, -2, -3 dot 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 minus infinity. These are integers. That means complete number. If the object is complete, the whole object, the representation these whole objects are called integers. Like if 1 roti is called 1 roti, 2 roti, 3 roti, these are the integers. If somebody eaten the half roti and 3/4 roti, that the part of the chapati, that is the representation in mathematics is called rational number. Today we will discuss more focus about on the rational number. Basically, rational numbers are basically fraction, or this is equal to ratio, and that is numerator upon denominator. Numerator upon denominator. If any numbers can be written in the form of numerator upon denominator, that is equivalent to P upon Q form, where Q must not be equal to 0. The question arises, why the Q is not equal to 0? If the Q is 0, then the mathematical condition is not satisfied. Like there is 1 roti and 0 part has been eaten. So there is no sense in class 9th, and in higher classes we will study about that, why this is not equal to 0. So that means the rational number, the numbers which can be written in the form of fractions, that means P upon Q form, where Q is not equal to 0. I hope this is understood. Now, we will insert the rational numbers between any two numbers. There are infinite numbers between any two numbers. That means again that there are the infinite irrational numbers or rational numbers and irrational numbers between any two numbers. Now we will insert the rational numbers between any two numbers. Example, insert 5 rational numbers between 3 and 4. There are two methods to insert a rational number between any two numbers. That is the method number 1. We know that there are infinite rational numbers between 3 and 4. That is 3 and that is 4. The 5 rational numbers like 3.1, 3.2, 3.3, 3.4 and 3.5. These are the 5 rational numbers between 3 and 4. Let's check it. This is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and 4. Right? Second method number 2, just write it into form of the fractions. That is 3 is equal to 3 upon 1 and 4 is equal to 4 upon 1. Now we need to insert 5 rational numbers. So look this one, these fractions 3 upon 1 and 4 upon 1. Now multiply the numerator and denominator by 5 plus 1, 6. So we need at least the 6 for the 5 rational number. Now 3 multiplied by 6 divided by 1 multiplied by 6, then fraction does not change. This is 3 upon 1. And second one, 4 into 6 divided by 1 into 6. So this is equal to 18 upon 6 and this is equal to 24 upon 6. Now we can increase the numerator and denominator unchanged. That is 19 upon 6, 20 upon 6, 21 upon 6, 22 upon 6 and 23 upon 6. Next the 24 upon 6. So these are the 5 rational number which are written in the form of P upon Q, where Q is not equal to 0. So these are the two methods to insert between the two numbers. Next examples, if we have to insert the rational number between the two fractions where the denominator is the same, like insert 4 rational number between 1 upon 2 and 3 upon 2. 1 upon 2 and 3 upon 2. We will follow the second method. We can follow this first method also. It is quite understandable. The solution is again 1 upon 2 and 3 upon 2. Denominator is the same and we need 4 rational numbers between these two fractions. Again, the numerator and denominator must be multiplied by the 4 plus 1, that is 5. That is 5. And 3 into 5, 2 into 5. This is equal to 5 upon 10. This is, the fractions remain unchanged. That is 15 upon 10. Now insert the numbers in increasing numerator order. That is 6 upon 10, 7 upon 10, 8 upon 10, and 9 upon 10. 6 upon 10, 7 upon 10, 8 upon 10, and 9 upon 10. These are the four rational numbers which lie between 1 upon 2 and 3 upon 2. The next examples, if the denominator is different, or like insert 5 rational number between 2 upon 3 and 3 upon 4. 3 upon 4. In this case, in these situations, first we have to make denominator same. First we have to take LCM so that the denominator will be same. The LCM of the 3 and 4, and the LCM of the denominator is 12. Let's write this is 12. 3 4s are 12. 2 into 4, and it is 12. 3 3s are 9. This is 8 upon 12, and this is 9 upon 12. It is 8 upon 12 and 9 upon 12. Now we have to insert the 5 rational numbers. That means we have to multiply by this at least, by the 6 for the more convenient. The 8 into 6 upon 12 into 6, this is 9 into 6 upon 12 into 6. This is equal to 48 upon 72, and this is 54 upon 72. Now write the numbers in increasing numerators. This is 49 upon 72. That is 50 upon 72. That is 51 upon 72. And this is 52 upon 72 and 53 upon 72. So these are 5 rational numbers which lie between 2 upon 3 and 3 upon 4. Student, these are the 3 different situations or conditions to insert the rational number between any 2 numbers. And now the question arises whether the 0 is the rational number or irrational number. So just check the book if you have the book and write the 0 in form of the P upon Q, where Q is not equal to 0. Okay, thank you students. Next day we will discuss another concept and some examples. Thank you.